So today we're going to be looking at combining different functions and creating a new function from the 2 or 3 that we've had. And so what we have is we're going to combine them through addition, subtraction, multiplication, and division. We see the way in which we can write the but the addition and subtraction of functions different ways. And so the first part of these notes is just giving you an idea of the different ways in which we can write those different combinations. So down here, we will actually combine f of x with g of x, where f of x is x cubed and g of x is the square root of x plus 1. So if we're going to add f plus g, and I'll go ahead and put parentheses around as we see up above how that can be written. We also know that that can be written as f of x plus g of x in that form as well, meaning the exact same thing. So we will take our f of x, which is x cubed, and we will add it with g of x, which is the square root of x plus 1. Seeing that I cannot combine, I have no like terms, that will be my final function. And so we can say that the addition of f of x plus g of x results in x cubed plus the square root of x plus 1 as our final answer. If we subtract the two functions from each other, I have f minus g of x, which can be written as f of x minus g of x, which results in x cubed minus the square root of x plus 1. And again, we do not have anything that we can combine together, and therefore we have our final answer as that is. If we're going to be multiplying the two functions, we can have f of x times g of x. Again, we will have x cubed times x plus 1, and that's the furthest that it can go with that. We've got our division, where we have f of x being divided by g of x, which results in x cubed divided by the square root of x plus 1. Square root in the denominator results in an irrational number, but we will go ahead and leave it as that is. Otherwise, if you wanted to, you could rationalize the denominator by multiplying both numerator and denominator by the square root of x plus 1. Let's go ahead and take this a little bit further, and let's add in another set of functions that we want to do those operations to. So let's say that f of x is let's say x squared, and let's say g of x is x squared plus 3. And so if we want to add these two together, we would have x squared plus 3, which results in 2x squared plus 3, adding those together. If we would be subtracting, we would have x squared minus, and since g of x is a quantity of x squared plus 3, I would put that in parentheses, understanding then that that subtraction sign would result in that next x squared being a negative, as well as that 3, as that negative would get distributed to everything inside that parenthesis. X squares cancel, so I would be left with just negative 3. If I have f of x times g of x, I would take x squared times x squared plus 3. Again, distributing everything inside the parenthesis, I would get x to the 4th plus 3x squared. The division would result in x squared being divided by x squared plus 3. And again, understanding, be very careful that g of x is the quantity x squared plus 3. These x squared cannot cancel, as this x squared is a term, not a factor, so that would be your final answer. Another way in which we can combine functions is through what we call composition of functions. And we say that, again, we're still playing around with an f of x and a g of x of both of those different functions, and we can write it as f of g of x can be written with an open circle in the middle. That does not represent multiplication. That is a symbol signifying composition. We can also write it as using parentheses. Again, we read this as f of g of x is how that is read if you would read that out loud. And so if we flip to the back page, we've got some composition that we're going to be working with here. We have f of x equals 2 to the x power, and g of x equals the square root of x plus 1. We want to find f of g of x. We always work from the inside out. We understand that this also could be written in that manner as well, using parentheses, and I kind of like this better because it shows that g of x is literally inside of f of x. So that means that I'm going to take my f, I'm going to locate that variable, and that variable happens to be in the numerator, not in the numerator, excuse me, as an exponent. And I'm going to just take that exponent, that variable, and I'm going to remove it. I'm going to replace it with an open box, which means that g of x, whatever g of x is, however big it is, that is going to go inside that empty box. So it becomes 2 raised to empty box square root x plus 1. And so that empty box gets replaced with whatever is g of x inside of g of x. Now if it's reversed, where I have g of f of x, where f of x now is inside of g, I'm going to look at g, and I see that I have the square root, there's the variable, replace the variable with an open box, and understand that whatever is in that open box, whatever I put inside that open box will be f of x. So 2 raised to the x power goes inside that open box plus x. That is how we work with compositions. Now, if we have composition of actual numbers, this is kind of cool because we actually end up with a value rather than just another function. And so what we'll do here is we'll see that g is inside of f, but instead of g being an x, g is going to be replaced with a 3. So I look at my g of x down here, and where that x is, I'm going to replace it with 3. So I'm going to start out with saying g of 3. So instead of x plus 1, that's going to be 3 plus 1, and I get 4. So now I'm going to work with f of 4. So now I go to my f function. Instead of x, I'm going to put a 4 in there. So I get 8 minus 3, which equals 5, and that is my final answer. Then I'm going to work on the second one. I'm going to start with f of negative 2. So I look at my f function, and instead of x, I'm going to put in negative 2 in that place. So that becomes negative 4 minus 3, which is negative 7. So now I'm going to take my g and replace the f of negative 2, because I know that f of negative 2 equals negative 7, so now it's going to become g of negative 7. So I go to my g function, I get negative 7 plus 1, and I get negative 6 as my final answer. Working with the problem down here, I have f of x equals x squared plus 4. And so I have first with my g of 3, and g of x equals the square root of x plus 1, so I'm going to work with my g of 3 first. I take the square root of 3 plus 1, which is the same thing as square root of 4, which equals 2. So now that 2 gets replaced in my f function. So instead of g of 3, I have gets replaced with 2, same value. So I'm going to have f of 2, 2 squared plus 4, 4 plus 4. My final answer is 8. Doing the same thing with g of f of negative 2, I have f of negative 2, so I have negative 2 squared plus 4, and I should have written it in proper form. Sorry about that. F of negative 2. Negative 2 squared is 4. 4 plus 4 is 8. And so my f of negative 2 gets replaced with 8. So that becomes g of 8. Go to my g function, which is the square root of x plus 1. So I get 8 plus 1, which is 9, square root of 9. My final answer is 3. Our final composition that we're going to be working with is actually working backwards. We do not know what f of x or g of x is, but we do know that h of x is going to be the square root of x squared plus 5. So knowing that that is my final composition of f of g of x, what could I use for f of x and of g of x? So I see here that here is my variable. So I could play around with that, and I could say, since g of x is on the inside, let's say that g of x is x squared. I'm just going to pull that out. If g of x is x squared, then what would f of x have to be? Well, f of x then would be the square root, because that would be x. That's what g of x would replace, plus 5. So double check my work on that. If I have f of g of x, and I need to replace g of x with whatever the variable is, so I would look at it as like this. There's my open box, plus 5. If I put x squared in there, would I get that final answer? And the answer is yes, I would. That is just one situation that would work. There are many others that you could have come up with. Well, maybe not many, but other situations you could come up with for that. But that is working backwards to find h of x, finding f and g of x given h of x.